This talk will be about privacy and why does privacy matter, how can we implement stuff on the blockchain, and how can we do very cool stuff on the XRP Ledger. So first things first, why does privacy matters? I think we can all agree on the fact that privacy is a fundamental right. It's essential to users and persons to preserve their freedom and protection of their sensitive data. However, what we've seen in the Web2 industry is that privacy is no matter at all. Like for big tech company or government, your privacy is not a big deal. It's more like your data are their data, right? And we have the luck and the opportunity with Web3 to make a change on this. However, it's very difficult because we are working on public blockchain, and this thing can maybe sound stupid, right? But public blockchains are public, which means that every information that is posted on this blockchain will last forever and will be publicly accessible. So why does privacy matter in public blockchains? The first and the most important thing is for security and risk purposes. Public and clear data can be exploited by attackers to identify potential targets or some specific behavior. If we think of MEV, MEV is basically this, is looking at the mempool, find some shim, and try to get money on this. It could be you as a person, and a thing that we need to keep in mind is when you are using a blockchain, basically you're anonymous only on the fact that there is no link between the real identity that you are and the address that you are using. So that's why privacy matters. Also, for autonomy and control of your data, we want the users to own their data. That's what all about Web3 is, and it's very important to keep this in mind. So when we are talking about private blockchain, I think you are thinking about stuff like Monero or Zcash, which are basically privacy coins. If you look at a Monero transaction, what you're gonna see is basically nothing. You don't know who have sent the fund and how many fund has been translated into transactions. However, this has big compliance problems. I think it's in South Korea, you can't buy Monero on any centralized exchange because for money laundering and all those purposes, it's very easy to do. And there is also some emerging technology, such as private mixnet. Maybe you heard about NEEM or Hopper. Those are things that allow you to basically mix the package of your information you're transmitting into internet. And so the people receiving it can't know what happened and who sent it. So in terms of transactions, to have private transactions, the end game will be to have some transactions that are compliant with the regulatory laws and keeping details hide from third party. But today we are not only using blockchains for transactions, we are also using blockchains for DID. And DID is a big deal, right? Because there is a lot of application building on top of blockchains. I'm talking about ticketing application or any application that is using blockchains for real use cases, at least real world use cases. Basically, you are thinning the border between your address and your real identity. Make it very easy to make link between you and your address and then having no privacy at all because it's a public network. So the idea to have privacy in decentralized identity is to reveal only the necessary data to a third party. The idea is still the same, giving ownership of data to users. The current state, there is some protocols that exist on EVMs. I'm thinking of Polygon ID. Heirloom is using it, so if you have signed with Heirloom at the venue, you have used Polygon ID. And the thing is that those kind of protocols are all based on ZK snarks, which make it very complicated for non-Web3 users to onboard and use those privacy protocols. So what we want to achieve here with the privacy in decentralized identity is to enable users to prove characteristic or on-chain or off-chain characteristic without leaking any data, and by having a simple UX UI. And the first step, we have to have a simple UX UI for Web3 people. So what can we build on the XRP Ledger?
Thank you, Thomas. So here I'm going to explain to you how we can implement privacy on the XRP Ledger, mainly through technologies such as ZK proofs. There's actually two types of ZK proof, ZK snark and ZK starks. Snarks stand for succinct non-interactive argument of knowledge proofs. They requires what we call a trusted setup. So we have a trusted third party which will share some big numbers, basically, between the other parties. And it's really complex. It's like a black box for anyone who don't actually know cryptography, which is a huge drawback for any use that requires trust, because you don't know what's happening inside of it. It's exactly like AI. ZK-SNART stands for Scalable Transparent Argument of Knowledge, requires no trusted setup, and much more computation. But ZK-SNART can also allow you to verify much bigger proof in the smallest time period, and it's way better for some uses. Whatever, both of these technology are like 50 years old both. I mean, the first paper about them were written 50 years ago. Anyway, here we are bringing a new kind of ZK proof, which are ring signatures. Ring signatures is based on the same cryptography as you use daily on the XRP Ledger or any other blockchain. It's elliptic curve cryptography. It's really simple. I mean, it's the same way. We just putting you in a group, so we don't know who the signer is, but we know this is a member of the group. For instance, here you have a group of 5 people, and one of them is the signer, maybe the patient, and he will make the signature using all public keys of the group, and then put it on chain or wherever he wants. Anyone can verify that one people of this group actually signed the message, but we don't know who. This can be used for many use cases, such as private voting or just private proof of ownership. That's what we use in Alice's ring protocol. The verification on chain is much lighter. It costs about 1 million gas to verify a signature with 300 people. So any attacker have one chance over 300 possibilities. Now let's dive into the Alice's ring protocol. Here we have a group. Each one of the group owns a certain amount of token. For the example here, it's 2 XRP. And Alice wants to prove to somewhere else, maybe you, that she owns at least 2 XRP, for instance, to a loan or something. Then she will use any public keys from any users, including hers, to build the ring signature. So the ring is created, the signature is now done. And as a verifier, maybe the bank, I can see that, okay, I have a group of people, and I can verify on-chain if any of them hold at least 2 XRP. Then I can do it very easily. Okay, the signature is valid. I know that Alice possesses at least 2 XRP. Maybe it's time for a quick demo?
Yeah, maybe a quick demo would be cool.
Let's go.
Is the video loading or not at all?
Yep.
Yeah, perfect. So on the demo, for instance, we are not live yet on Gem Wallet. We have forked Gem Wallet, and we have implementing all the sign-in process inside of it. So you just download the extension and basically run it as a developer mode on your Mac. But it will be soon available. We have launched the PR and so on, and we are in contact with the team to merge everything. So when you install your wallet, you're gonna set up it. So here you're gonna create a new seed and so on. What's important to note is that you need to have 2 addresses. So there is one address we're gonna sign, and another one we're gonna hold the proof. The proof is considered as an NFT on the XRPL, and basically all the metadata of the signatures are stored on ePFS. So you're gonna set up your wallet, go on the testnet, fund the wallet, and then you're gonna set up the different argument of what you want to prove. For instance, you're gonna say you want to prove XRP, USD, and so on, set a specific message. So here we have 2 wallets. We are funding them, takes some time, and we're gonna take the address of the first one, connect with Gem, reload the page, connect with Gem, and take the address of the first wallet. So here we can see that we have the prover address, which is RW, and the secret address. So the secret address will be the second one, and the prover address the fund one. Here we're gonna prove that we own 100 XRP with 20 people in the ring. So we're going to hide ourselves with 20 other people. We have passed your secret address, sign a message to get the data from the backend, and then you have your ring. Here, this is where the magic happens. You're just going to sign a classic sign message and make your ring signatures. It's as easy as this. There is no need to scan QR code, do stuff with ZKey, get your first, I don't know what it's called, your first credentials on Polygon ID, then re-sign it, and so on. It's as easy as just signing with one button. And then you're going to switch to the other address to basically mint the NFT. The NFT is minted in the backend, so there is no trace on the blockchain of who has minted the NFT. So there is total privacy there because it comes from an address, and then you just accept the offer. There is no trace of the first address. You sign in Gem, it's minting, and in the end, we'll have NFT accept offers, which you're going to claim, and here you have your proof. So you can see that you have your address, the amount you prove, 21 people in the ring, the transaction hash, and the details of the ring. In the end, you are hiding with all those people and you don't know who I am. And you just prove that you own 96 XRP. Yep. So that's the demo. I think we have some time for questions. If you got the, yeah, perfect. So is there any question?
Yes, thank you for that. Just wondering, if let's say I want to submit a payment from myself to you, when that transaction happens, and if I open it in the Block Explorer, what is it going to show? Like, do you have an example of that?
So I don't have example on the presentation, but if we go back to this slide.
It has to be an account and a destination address in that transaction, correct?
Yeah, if we go to the mint transaction, basically, it will just say that the address in the backend with handling all the mint of the NFT, I just minted this NFT. And then you got like the transaction after the accept offer, which is the address in the backend, which is a public address for generating those proofs, and the prover address. So there is no leak of the address we have signed the message in terms of like blockchain public data.
Okay, so the backend controls some sort of private key, and then
the backend controls a private key to mint NFT, basically.
Okay. Isn't that considered, and not making a judgment call here, but isn't that pretty much like what mixing services do in some way? There's some sort of centralized server that will help. There is
some centralization at the moment. The idea is then to basically expand it, and so everything can be run in local. The idea is just to have like a simple workflow for users for the moment to have like you just claim in the backend, because if you don't have this, if you really want to do this well, you have to fund, on the mainnet at least, fund the wallet to have 10 XRP that come from not the address you want to prove. So you have to hide this. Then you have to, OK, I have this thing. I need to mint, but there is this address, and so on. So it's really just something to safeguard privacy more than controlling the thing. Basically, all the computation is done in the front end. Everything is done in Gem Wallet. So it's more to have a user-friendly workflow than anything else.
Isn't it something like having a finite number of public keys, public and private keys, rather than a ZK? Like even in Bitcoin, you can get a privacy by choosing different public and private key, and this one is also will be similar, but it is not as good as the zero-knowledge proof.
So it's not as good as the ZK snark in the fact that basically you are in 1 in n for the privacy. However, if you do if we go back in the ZK snark, how you do this basically with the ZK snark? So what you're going to do is you're going to have a Merkle tree that contains all the addresses of public key. You're going to pass this Merkle tree in your circuit, and then you're going to take basically a storage proof or something, or you're going to take this, the Merkle tree, which is a storage proof, and then you're going to take the CDSA signature, and you're going to verify that the signature match the Merkle tree. Okay, but to verify the circuit, you need to have this public data. Like the storage proof must be public to verify the circuit. So in the end, there is the ring, which is the Merkle proof, and the anonymity is the same. Like you have to have public data to show that you're part of the group.
Over time, then the privacy will be leaked, right? Over a time, if I collect all the data, what the transaction has happened, I can make a link.
Yeah. So if there is someone who is making a transaction and then go under the threshold, the proof is not valid at all. Like we consider the proof to be invalid. We don't We don't consider like, okay, there is 100 people in the ring, one have not the threshold, the proof is valid at 99%. No, that's not the case. Like, the proof is not valid at all. It's only Boolean. And there is no leak of privacy if you do like multiple signatures, because the ring is never the same.
Moreover, there's a compliance advantage to use this kind of proof, because it's really easy for anyone to check that any member of the group has legit funds that are not from any hack or whatever you want.
Another question over here.
How you doing? So first, I wanted to ask if there's what's the current size limit on the ring?
Can you repeat the question, please?
What's the current size limit of the ring?
There is no current size limits. I mean, you can use 1 million public keys if you want. The only thing is that the proof generation will take some more time, but that's it.
It's more computation problem than anything else. I mean,
yeah.
Basically the limit size will be the number of accounts there is on the XRP ledger. So for instance, it's like 5 million, and because there is on the XRPL like 2 elliptic curves, you divide it by 2, so it will be like 2 million, and you need to have a threshold that's met. So if you are the address on the XRPL that have the most XRP, you can make a private proof that you own the most XRP because you are the only one. But if there is like 1 XRP, I think everyone has 1 XRP, so you can hide it with the entire network that have the same elliptic curve than you.
I got it. And the second thing is if you can expand on what you just said about compliance.
Yeah, of course. On zk-SNARK, you cannot easily tell, okay, I have the threshold amount, but my funds are compliant, because the proof is much more harder to create and to create mathematically, and then to build with your computer. Then ring signatures allow you to say, okay, I have a ring, which is a group with many public keys. Then you can check any of these people, and all of them are compliant with your requirements.
You can do, because the ring is public, you can do your due diligence to any member of the ring and verify if there is like one address which not my due diligence. So let's say you're a bank, some guys want to show you that he holds Bitcoin or XRP, you see that there is one address with link to a hack. You could say, okay, this proof is not valid because there is this thing that not match the threshold of being my due diligence. Make another proof. And if you can't do another proof, this means this guy basically is the guy who has made the hack.